Hello everyone, today we'll continue the series of vector analysis and today we'll see questions related to gradient and directional derivative. So let's see question number 1, which is asked in Forest Service examination in 2022. So the question 1 says that determine the constants a, b and c so that the directional derivative of this scalar at this point has maximum magnitude in the direction parallel to z-axis. So herein we are supposed to find values of constant a, b and c such that the direction derivative of this scalar in the direction parallel to z-axis has maximum magnitude of 88 at this point. So let's see how we can do that. So first of all, we need to calculate basically the direction derivative in direction parallel to z-axis. So let r cap basically represents the direction of z-axis. So it will be 0 I cap plus 0 j cap plus 1 k cap. So this is the direction parallel to z-axis. Now I need to evaluate the gradient first in order to calculate the direction derivative. So gradient of phi will be basically del by del x I cap plus del by j cap plus del by del z k cap of phi. So if I evaluate it, it will be equals to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So it can be simplified as, if I take partial derivative of phi with respect to x, so it will be a y square plus 3cz square x square I cap plus direction derivative of phi with respect to y will be 2axy plus bz j cap, and the direction derivative of basically the partial derivative of phi with respect to z will be by plus 2cz x cube k cap. So this is the gradient of phi. Now the direction derivative in direction parallel to z-axis will be direction derivative in direction parallel to z-axis will be basically given by a product of dot product of the gradient phi and the direction. So it will be a y square plus 3cz square x square I cap plus 2axy plus bz j cap plus by plus 2cz x cube k cap, and its dot product with the direction, that is 0 I cap plus 0 j cap plus k cap. And if we evaluate this dot product, we will be left with only this term, that is by plus 2cz x cube. Now the question says that the magnitude of direction derivative in the direction parallel to z-axis at this point is maximum, that is 88. So we need to equate the magnitude at this point with 88. Now the direction derivative, let's just denote it with d. So d at this point, that is 1 comma 2 comma minus 1, will be equals to b times 2 plus 2c times minus 1 times 1 cube, that is basically equals to 2b minus 2 of c. Now the question says that its magnitude is basically equals to 88. That means 2b minus 2c is equals to 88, and if I simplify it, it will give me b minus c is equals to 44. So from here I got a relation in b and c. So my b and c are such that b is equals to c plus 44, and c can take basically any real value. Based on that we can evaluate b, and if you observe that there is no relation that we got related to a, so a can take any arbitrary real value. So from here we can say that b is equals to c plus 44, and c and a can take any arbitrary real value. Now let's move on to discuss the next question. So the next question is, this was asked in 2021 in Forest Service examination, and it's a 8-marker question. So question says that they have given us a vector f and we are supposed to prove these 3 relations. So let's see how we can do that. So firstly, here our vector is basically x I cap plus y j cap plus z k cap, and this is basically gradient of phi, which is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So firstly let's just prove these 2 relations, this one and this one equals to 0, and then we'll claim that this one is also equals to 0. So if I evaluate dot product of f vector with r vector, so it will be equals to x times this term, basically the component with respect to I vector, x times y del phi by del z minus z del phi by del y plus y into z times del phi by del x minus x times del phi by del z plus z into this term, that is x times del phi by del y minus y times del phi by del x. Now if I simplify it, it will be equals to xy del phi by del z minus xz del phi by del y plus yz del phi by del x minus xy del phi by del z plus xz del phi by del y minus zy del phi by del x. Now if we see that this term and this term balances each other, likewise this term and this term balances each other, and this is balanced by this one, so it is equals to 0. So from here we have shown that dot product of f vector and r vector is basically equals to 0. Now next thing that we want to show is that dot product of f vector with gradient phi is also equals to 0. So if we evaluate this, so it will be equals to y del phi by del z minus z del phi by del y times del phi by del x plus z del phi by del x minus x del phi by del z times del phi by del y plus x del phi by del y minus y del phi by del x times del phi by del z. Now if we see that, if we just distribute these terms inside the bracket, so we'll get y times del phi by del z times del phi by del x minus z times del phi by del y del phi by del x plus z times del phi by del x into del phi by del y minus x times del phi by del z into del phi by del y plus x times del phi by del y into del phi by del z minus y times del phi by del x times del phi by del z. Now if you observe that this term and this term balances each other, likewise this term and this term balances each other, and this is balanced by this one, so this dot product is again equals to 0. So now we are left to show the third relation, that is this one, that is f vector minus cross product of r vector with gradient phi is equals to 0. Now in order to evaluate it, first we need to find this thing, that is cross product of r vector with gradient phi. So cross product of r with gradient phi will be equals to I cap j cap k cap x y z, and so this will be equals to y del phi by del z minus z del phi by del y minus j cap x del phi by del z minus z del phi by del x plus k cap x del phi by del y minus y del phi by del x. Now if you see that, it will be basically equals to, if I just so if I just write it as I cap times y del phi by del z minus z del phi by del y, and if I pull negative sign from this bracket, so it will be equals to plus j cap z del phi by del x minus x del phi by del z plus k cap x del phi by del y minus y del phi by del x. Now if you observe that, this is basically the f vector that is given to us. So from here we can say that f vector minus r vector cross grad phi is basically equals to 0. So this is the third relation that we are supposed to prove. Now if you see that all these three terms are equals to 0, so from here we can equate them as well. So we got the relation that is f vector minus cross product of r vector and grad phi is equals to dot product of f vector with grad phi, which is equals to dot product of f vector with r vector, and all these three are equals to 0. This proves our second question. This is the relation that we were supposed to prove. Let's move on to discuss the next question. So the next question is, it is also asked in 2021 Forest Service examination. So the question says that a vector and b vector are any two vector point functions defined on Euclidean space R cube. So basically a vector is something of form a1 I cap plus b1 j cap plus c1 k cap, and likewise b vector is something of form b1 I cap plus b2 j cap plus b3 k cap. So it says that derive the vector identity for this. So we were supposed to evaluate some vector identity for gradient of basically a vector dot product with b vector. So we are supposed to evaluate a vector identity, and further they have given us some so further we are supposed to verify that identity for these given informations. So let us first derive the identity. So identity is basically, I'll first just state the identity because it's a quite famous identity, and then we'll move on to prove it. So our claim is to show that gradient of basically a vector dot b vector is equals to b vector dot gradient a vector plus a vector dot b vector plus b vector cross product with curl a vector plus a vector cross product with curl b vector. So this is the identity that we are supposed to evaluate. So first thing is, what we'll do is we'll evaluate this, that is a vector cross curl b vector. So we know that curl of any vector x is basically equals to cross product of this inverse delta, and then this is basically curl of any vector. So this thing, that is a vector cross curl b vector, will be equals to a vector cross b vector. Now this symbol basically can be opened as del by del x I cap plus del by del y j cap plus del by del z k cap. So we'll be writing it as summation of del by del x I cap, because otherwise it will be too much to write. So this is the short form that we'll be writing for this. So it will be equals to a vector cross summation del by del x I vector cross b vector. Now we can write it as, what we can do is we can just pull out this summation outside. So it will be equals to summation a vector cross del by del x I cap cross b vector, which can be further written as summation a vector cross I vector cross del b vector by del x, which can be further written as, we know a relation that is a vector cross b vector cross c vector. This is same as a dot c minus, this is same as a dot c times b minus a dot b times c. So using this relation, this basically opens up as summation a vector dot del b by del x times I cap minus a vector dot I cap times del b vector by del x. Now this can be simplified as, so what we can do is we can distribute this summation sign over the two terms, so it will be equals to summation a vector times del b by del x I cap minus summation a vector times dot product of a vector with I times del b by del x. Now it can be like, we can write it as like this, that is summation a vector dot del b by del x I cap minus summation a vector dot I vector times del by del x times b vector, which will be basically equals to summation a vector dot del b by del x I cap minus summation, we can take the summation side inside, so it will be equals to a vector dot summation I vector del by del x times b vector, so it can be written as summation a vector dot del b by del x I cap minus a vector times this times b vector. Now if we see, so we just evaluated a relation that is a vector cross product with curl b vector is equals to summation a cap dot del b by del x I cap minus a vector dot this times b vector, and if I take this term on the left hand side, so it will be equals to this plus times b vector, which is equals to summation a vector dot del b by del x I cap. Now if likewise if I evaluate this, that is b vector times curl a vector, so it will be equals to, basically it will be equals to summation b vector dot del a by del x I cap. Now let's name this as term 1 and this as equation 2. Now if I add on equation 1 and equation 2, so what I'll get is a vector times curl b vector plus b vector times curl a vector plus a vector, and this will be equals to summation a vector dot product del b by del x I cap plus summation b vector dot product del a by del x I cap. Now I can pull out this summation and summation outside, so it will be a vector dot del b by del x I cap plus b vector dot del a by del x I cap, which is equals to summation I cap del by del x a vector dot b vector, which is gradient of basically a vector dot b vector. So I got a relation that is my gradient of a vector dot b vector is equals to this summation, and that's what we have claimed earlier. Usually it's better to look up for these kind of relations earlier, because it's really difficult to follow through in examination if you don't know it beforehand. So let's verify this relation for given phi and psi. So phi is given to us as 3x square y, 3x square y, and psi is given to us as xz square minus 2y, xz square minus 2y. So we were supposed to evaluate gradient of gradient phi dot gradient psi. So in order to verify this relation for this, first we need to evaluate what is gradient phi and then gradient psi. So gradient phi will be equals to del by del x, basically 6xy I cap plus 3x square j cap plus 0 k cap. Likewise, grade psi will be equals to z square I cap minus 2j cap plus 2xz k cap. Now if I evaluate this, that is basically dot product of these two, so it will be equals to 6xyz square minus 6x square plus 0 times 2xz, which is equals to 6xyz square minus 6x square. Now if I again evaluate gradient of this term, so it will be equals to 6yz square minus 12x I cap plus 6xz square j cap plus 12xyz k cap. Now I need to evaluate all these terms in order to see if that is equals to this. Now we know that curl of gradient of something, let's say some vector, some scalar, let's say alpha, is equals to 0. So herein if we evaluate these terms, that is a cross product of a vector and curl b vector, so it will be in the question that for which we are verifying, a vector is basically gradient of phi and b vector is basically gradient of psi. So if I evaluate this, that is a vector cross curl b vector, so it will be equals to gradient of phi time cross product with curl of grad psi, so this will be equals to 0. Likewise if I evaluate this, that is b vector cross product curl a vector, again it will be equals to 0. So these two terms reduces to 0. Now we need to evaluate this, that if I evaluate this term, that is a vector dot this times b vector, so a vector is basically grad phi, which is equals to 6xy I cap plus 3x square j cap plus 0 k cap dot del by del x I cap plus del by del y j cap plus del by del z k cap times grad psi, so it will be equals to 6xy del by del x plus 3x square del by del y times grad psi, which is basically z square I cap minus 2j cap plus 2xz k cap. So if I evaluate it, it will be equals to 6xy times 2z k cap plus 3x square times 0, that is 12xyz k cap. Likewise if I evaluate another term, that is this, so my b vector is basically grad psi, which is z square I cap minus 2j cap plus 2xz k cap times del by del x I cap plus del by del y j cap plus del by del z k cap multiplied with grad phi, which will be equals to z square del by del x minus 2 del by del y plus 2xz del by del z times grad phi, which is basically equals to 6xy I cap plus 3x square j cap plus 0 k cap, and it simplifies to z square times 6y I cap plus 6x j cap minus 2 times 6x I cap plus 2xz times 0, which simplifies to 6yz square I cap plus 6xz square j cap minus 12x I cap. Now if I add on these two terms, so this can be simplified as 6yz square minus 12x I cap plus 6xz square j cap. Now if I add in this term with this term, so what I'll get is so it is equals to 6yz square minus 12x I cap plus 6xz square j cap plus 12xyz k cap, which is basically equals to this. Which is equals to grad of grad phi dot product with grad psi. So we have proved the relation because these two terms earlier reduced to 0. So the given identity is satisfied by given phi and psi. So this completes our question. Let's move on to see the next question. So the next question is, prove that for a vector A, dot gradient of dot product of A vector with r vector is equals to A vector only, and here r vector is this, and r is basically absolute value of this r vector, and it further asks us that is there any restriction on A vector, and further we are supposed to evaluate another relation that is given to us, and they have asked us to give an example to verify the above relation that we have proved. So let's see how we can evaluate the first relation. So first let's evaluate dot product. A is any given vector, so we can assume A vector as this: A1 I cap plus A2 j cap plus A3 k cap. You can do it directly as well, that's totally up to you. So if I evaluate dot product of A vector with r vector, so I'll get A1x plus A2y plus A3z. Now if I evaluate its gradient, so it will be equals to del y del x A1x plus A2y plus A3z I cap plus del by del y A1x plus A2y plus A3z plus del by del z A1x plus A2y plus A3z, which simplifies to A1 I cap. Here we have j cap and k cap as well, which simplifies to A1 I cap plus A2 j cap plus A3 k cap, which is equals to A vector only, and that's what we were supposed to show. We are supposed to show that this relation holds. Now the next question is there any restriction on A vector? So restriction on A vector is that it must be some constant vector. A vector must be constant. That is, it shouldn't be dependent on variables x, y and z. It shouldn't be dependent on x, y and z. So for example, you can see that if I take, let's say, my A vector as this only, let's take the simplest example, that is x I cap y j cap plus z k cap. You can take any other example as well. So if I evaluate A vector dot r vector, so it will be equals to x square plus y square plus z square, and if I evaluate its gradient, that is it will be equals to 2x I cap plus 2y j cap plus 2z k cap, which is basically 2 times of a vector, which is not equals to a vector. So this is the restriction that is there on a vector. Now we are supposed to prove the another relation, that is this, and here a vector and b vector are any two arbitrary vectors. So in order to evaluate it, first we need to evaluate this term, because we'll be using it to show the relation. So if I evaluate gradient of 1 by r, so it will be equals to del by del x I cap plus del by del y j cap plus del by del z k cap times x square plus y square plus z square raised minus 1 by 2, because my r is equals to absolute value of r vector, which will be square root of x square plus y square plus z square. And since here we are evaluating a gradient of 1 by r, so because of that this term is basically 1 by r. So if I evaluate it, it will be equals to minus 1 by 2 times x square plus y square plus z square raised minus of 3 by 2 times 2x I cap plus 2y j cap plus 2z k cap, and it simplifies to, we can pull out 2 from all these 3 terms and that will be balanced by this 2, so it will be equals to minus x square plus y square plus z square raised minus 3 by 2 times r vector, which I can write as minus r raised minus 3 times r vector, which is same as writing minus of r vector divided by r cube. Now if I evaluate, another thing is, that is if I evaluate dot product of b with this gradient of 1 by r, so it will be equals to b vector dot gradient of 1 by r, it will be equals to minus of, if my b vector is, let's say my b vector is basically equals to b1 I cap plus b2 j cap plus b3 k cap, so this will be equals to minus of b1 x plus b2 y plus b3 z divided by r cube. Now again we need to evaluate gradient of this term, so it will be equals to grad of b vector dot grad 1 by r, so it will be equals to del by del x I cap plus del by del y j cap plus del by del z k cap times, I am writing this minus here, b1 x plus b2 y plus b3 z divided by x square plus y square plus z square raised 3 by 2. So it will be equals to minus summation I del by del x times b1 x plus b2 y plus b3 z divided by x square plus y square plus z square raised 3 by 2. So if I evaluate it, it will be equals to minus summation I x square plus, we are supposed to evaluate partial derivative of this term with respect to x, so it will be x square plus y square plus z square raised 3 by 2 times b1 minus b1 x plus b2 y plus b3 z times 3 by 2 x square plus y square plus z square raised 1 by 2 times 2x divided by x square plus y square plus z square raised 3, which will be equals to minus summation iota. From this numerator term we can pull out x square plus y square plus z square raised 1 by 2. So we'll be left with x square plus y square plus z square times b1 minus b1x plus b2y plus b3z times this 2 balances this one, x divided by x square plus y square plus z square raised 5 by 2, which can be further simplified as minus summation I b1 divided by x square plus y square plus z square raised 3 by 2 plus summation I b1x plus b2y plus b3z times x divided by x square plus y square plus z square raised 5 by 2, which can be written as minus summation I b1 divided by r cube plus 3 summation I b vector dot r vector times r vector divided by r raised 5, which is equals to minus b vector divided by r cube plus 3 times b vector dot r vector okay, so I did a mistake here we have summation over x, so this summation we'll need to remove this summation if we are writing r vector here, or we need to write it as this summation x, which will be 3 times b vector dot r vector times r cap divided by r raised 5. Now if I evaluate a vector dot product with this, it will be equals to a vector dot product with b vector dot grad 1 by r, which will be equals to minus a vector dot b vector divided by r cube plus 3 times b vector dot r vector times a vector dot r vector divided by r raised 5, and this is exactly what we are supposed to prove, so we can write it as 3 times b vector dot r vector dot a vector divided by r raised 5 minus a vector dot b vector divided by r cube. So this is the relation we have proved. Now it further asks us that give an example to verify the above. So you can choose any arbitrary b and a vector. So you can choose a vector as, let's say, I cap plus j cap plus k cap. Likewise you can choose b vector as this, let's say 2i cap plus 2j cap plus 2k cap. You can choose any other as well, it's totally up to you. So, and our r vector is basically xi cap plus yj cap plus zk cap. Now if I evaluate the term on the right hand side, so b vector dot r vector will be equals to 2x plus 2y plus 2z. Likewise a vector dot r vector will be equals to x plus y plus z. So my right hand side will be equals to 3 times 2x plus 2y plus 2z times x plus y plus z divided by r raised 5, that is x square plus y square plus z square raised 5 by 2 minus 2 plus 2 plus 2, because a vector dot b vector will be equals to 2 plus 2 plus 2 divided by x square plus y square plus z square raised 3 by 2. and it simplifies to 6 times x plus y plus z square minus 6 times x square plus y square plus z square divided by x square plus y square plus z square raised 5 by 2. And if I pull out 6, so it will be equals to, and if I open this whole square relation, it will be x square plus y square plus z square 2xy plus 2yz plus 2xz minus x square minus y square minus z square divided by x square plus y square plus z square raised 5 by 2. These terms can be balanced out, so it will be equals to 12 times summation xy divided by r raised 5. Likewise, we can evaluate LHS as well and see that both these things are equal only. So let's move on to discuss the next question. So the next question says that prove the relation this for any two vector points f and g, and it further says that construct one example in 3 dimensions to verify this identity. So firstly, let's prove the relation, that is grade square of fg, which is also notation for Laplace. So it can be written as del of dot product of del times del fg. Now I can distribute this del over f and g, so it will be f times del g plus g times del f, which can be further written as del dot product with f times del g plus del dot product with g times del f, which can be written as del dot f times del g plus f times del square g plus del times g times del f plus g times del square f. Now if I simplify it, it can be written as f times del square g plus 2 times del f del g plus g times del square f. And this is the exact relation that we are supposed to prove. Now the question further asks us that for any two vector points, verify this relation. So for time being, let us assume that f r theta phi is, let's say, equals to r, and g of r theta phi is, let's say, equals to theta. Now del square of f is basically equals to del square of f by del r square plus 1 by r square times del square of f by del theta square plus 1 by r square sine square theta times del square f by del phi square plus 2 by r times del f by del r plus cot theta divided by r square times del f by del theta. Now if I plug in value of f here, so it will be equals to, this term will become 0. Likewise, this term will also become 0 because there is no term related to theta. This term again reduces to 0, so we'll be left with 2 by r times 1. Yeah, this term will also become 0. So from here I got del square f is equals to 2 by r. Likewise, I can evaluate del square g, which will be equals to del square g by del r square plus 1 by r square del square g by del theta square plus 1 by r square sine square theta times del square g by del phi square plus 2 by r times del g by del r plus cot theta divided by r square times del g by del theta. Now if I plug in value of theta here, this term reduces to 0, this again reduces to 0. We'll be left with only the last term, that is cot theta divided by r square times 1, which is equals to cot theta divided by r square. So, and if I evaluate del square of fg, that is r theta, so it will be equals to, we'll be left with the last two terms only, so it will be equals to 2 by r times theta plus cot theta divided by r square times r, which is equals to 2 theta divided by r plus cot theta divided by r. Now let's evaluate the expansion as well, that is f times del square g plus g times del square f plus 2 times del f times del g. Now if I evaluate f times del square g, so it will be equals to r times cot theta divided by r square, plus if I evaluate g times del square f, so it will be equals to, g is theta and del square f is 2 by r plus 2 times del f and del g. So we need to evaluate first del f and then del g. So del f is given by e r cap del f by del r plus e theta cap by r times del f by del theta plus e phi cap by r sin theta times del f by del phi. And here ei's are basically the directions. So if I plug in the value of f here, that is r, so it will be equals to e r cap, another terms will reduce to 0. Likewise, if I evaluate del g, that will be equals to e theta cap divided by r. Now if I plug in the values, like if I put evaluate del f times del g, which will be equals to e r cap e theta cap by r, which will be 0 only because these two directions are at 90 degree to each other, so this term reduces to 0. So from here we got that del square of fg will be equals to f times del square of g plus g times del square of f plus 2 times del f dot del g. So we have proved the given relation for specific example as well. Let's move on to discuss the next question. So the next question says that find the direction derivative of this scalar along the tangent to this curve at the given point, and it is asked in a civil services examination in 2019. So first let us evaluate the tangent for the given curve. So tangent of given curve will be equals to del by del x I cap plus del by del y j cap it will be equals to, basically it's in parametric representation, so it will be equals to I cap plus derivative of this, that is 2t j cap plus 3t square k cap. Let's denote it with some a vector. So if I evaluate this, so it will be equals to I cap plus 2t j cap plus 3t square k cap divided by square root of 1 plus 4t square plus 9t raised 4. And we need to evaluate the direction derivative along the tangent at point 1, 1, 1. So at that point tangent will be I cap plus 2j cap plus 3k cap divided by square root of 14. Now let's evaluate gradient of given scalar. Let's name that as phi for time being. So it will be equals to del by del x I cap plus del by del y j cap plus del by del z k cap times xy square plus yz square plus zx square. So it will be equals to I times y square plus 2xz plus j times 2xy plus z square plus k vector times 2yz plus x square, and then the direction derivative will be equals to grad phi times the tangent that we just evaluated, a cap, at the given point. So it will be equals to, okay, we need to evaluate grad phi also at given point, that is 1 comma 1 comma 1. So it will be equals to 3 I cap plus 3 j cap plus 3 k cap. Now if we do dot product of grad phi with a cap, so it will be 3 plus 6 plus 9 divided by square root 14, which is 18 divided by square root 14. So this is the direction derivative of given scalar along the tangent to the given curve. Let's move on to discuss the next question. So the next question is derive basically del square in spherical coordinates, and further it asks us to compute it for this scalar in spherical coordinates only. So in order to derive a del square in spherical coordinates, we'll look at its general formula. So del square f is basically equals to 1 by h1 h2 h3 times del by del u1 h2 h3 divided by h1 times del f by del u1 plus del by del u2 times h3 h1 by h2 times del f by del u2 plus del by del u3 times h2 h1 by h3 times del f by del u3. And in spherical coordinates, u1 is basically equals to r, u2 is theta, and u3 is phi, and h1 is basically equals to hr, which is 1, h2 is equals to h theta, which is r, and h3 is equals to h phi, which is r sin theta. Now if I plug in all the values of hi's and ui's, so I'll get my del square f in spherical coordinate as 1 by r square sin theta times del by del r h2 times h3, that is r square sin theta, times del f by del r plus del by del theta into h1 times h3, that is r sin theta, divided by h2, that is r, times del f by del theta plus del by del phi times h2 h1, that is r, divided by h3, that is r sin theta, times del f by del u3, that is del phi. Now if I simplify it, it will be equals to 1 by r square sin theta times del by del r into r square del f by del r plus del by del theta into this r is balanced by the 1 in numerator, sin theta times del f by del theta plus del by del phi times 1 by sin theta times del f by del phi, which can be further simplified. We can write it as 1 by r square sin theta. Here we have sin theta as well, so this sin theta can be pulled outside because we are partially differentiating it with respect to r. So it will be sin theta times del by del r square del f by del r plus del by del theta into sin theta times del f by del theta plus 1 by sin theta times del by del phi del f by del phi. It can be again further simplified, like you can distribute this partial differentiation inside the bracket and so on, but we'll leave it here. We'll calculate basically del square for this function. So here my f is, like we need to evaluate del square for f equals to x divided by x square plus y square plus z square raised 3 by 2. So this is not in spherical coordinates. So first thing that we'll do is we'll change it into spherical coordinates. So in spherical coordinates, x is equals to basically r sine theta cos phi, y is equals to r sine theta sine phi, and z is equals to r cos theta. Now if I plug in values of x, y and z in f, so I'll get my f as r sine theta cos phi divided by x square plus y square plus z square will basically give me r square raised 3 by 2, which is equals to r sine theta cos phi divided by r cube, which is equals to sine theta cos phi divided by r square. Now first thing is that I need to evaluate a partial derivative of this f with respect to r, theta and phi. So let's do that. So del f by del r will be equals to minus 2 by r cube times sine theta cos phi. Del f by del theta will be equals to cos theta cos phi divided by r square, and del f by del phi will be equals to minus sine theta sine phi divided by r square. So if I plug in these values, or let's just plug in these values in the formula that we evaluated. So del square f will be equals to 1 by r square sine theta times sine theta multiplied by del r square times del f by del r, that is minus 2 by r cube sine theta cos phi plus del by del theta times sine theta into del f by del theta, that is cos theta cos phi divided by r square plus 1 by sine theta times del by del phi into del f by del phi, that is minus sine theta sine phi divided by r square. So let's just simplify it. So it will be equals to 1 by r square sine theta times sine theta into del by del r, this r square balances it, so it will be equals to minus 2 by r sine theta cos phi plus del by del theta divided by 2r square sine 2 theta cos phi plus 1 by sine theta into del by del phi times minus sine theta sine phi divided by r square, which can be further simplified as 1 by r square sine theta times sine theta into, this can be evaluated as 2 by r square sine theta cos phi plus 1 by 2 r square times cos phi into cos 2 theta, 2 into cos 2 theta plus 1 by sine theta into minus sine theta by r square times cos phi. Now if we simplify it further, so it will be equals to 1 by r square sine theta times 2 sine square theta cos phi divided by r square plus 1 by r square times cos phi cos 2 theta plus, or it is minus only, minus cos phi divided by r square, and I can pull out this r square, so it will be equals to 1 by r raised 4 sine theta times 2 sine square theta, which we can write it as 1 minus cos 2 theta into cos phi plus cos phi into cos 2 theta minus cos phi, which is equals to 1 by r raised 4 sine theta times cos phi minus cos phi times cos 2 theta plus cos phi times cos 2 theta minus cos phi. This cos phi balances this and this one balances this, so this is equals to 0. So we got del square of given f as equals to 0, and so the value of this in spherical coordinates is basically equals to 0. Let's move on to discuss the next question. So the next question is find the angle between the tangent at a general point of the curve whose equation are this and the line is this. So what we are supposed to do, they have given us a parametric form of a curve, that is this. A tangent is drawn to this curve at any general point, let's say alpha, beta, gamma. Then we are supposed to tell the angle between that tangent to this curve and this given equation of line. That's the question. So from here, equation of curve can be written as 3t I cap plus 3t square j cap plus 3t cube k cap. Now if I calculate dr cap by dt, so it will be equals to 3 I cap 6t j cap plus 9t square k cap. So this is the equation of tangent. Likewise, I can evaluate this. I can write equation of line as, that is given to me is y equals to z minus x equals to 0. So I can write it in symmetric form, that will be y divided by 0 equals to x divided by 1 is equals to z divided by 1. So from here, R2, basically direction of this line will be I cap plus 0 j cap plus k cap. So from here cos theta will be equals to r1 cap dot r2 cap divided by absolute value of r1 times absolute value of r2. So from here, if I evaluate r1 dot r2, so this is basically my r1 cap, basically the equation of tangent. So r1 dot product with r2 will be 3 plus 9t square divided by square root of 1 plus 1 divided by square root of 3, that is 9 plus 36t square plus 81t raised 4, which can be simplified as 3 plus 9t square divided by square root 2 divided by 9 times 1 plus 4t square plus 9t raised 4, which is basically equals to 1 plus 3t square divided by square root 2 multiplied by 1 plus 4t square plus 9t raised 4. So since there is no specific point given at which we need to evaluate the angle, so this is basically the angle between the tangent to the given point at any general tangent to the given curve at any general point and the given equation of line. Let's move on to discuss the next question. So this question says that find the function fr such that this relation holds and this is also true. So grad f is given to us as r vector divided by r raised 5. Now if I write it in extended form, grad f will be equals to del f by del x I cap plus del f by del y j cap plus del f by del z k cap, and it will be equals to x I cap plus y j cap plus z k cap divided by x square plus y square plus z square raised 5 by 2. Now if I compare these, so from here I'll get my del f by del x is equals to x by x square plus y square plus z square raised 5 by 2. Likewise I can calculate del f by del y, which will be equals to y divided by x square plus y square plus z square raised 5 by 2, and del f by del z will be equals to z divided by x square plus y square plus z square raised 5 by 2. So if I evaluate it, like if I integrate this term, so I'll get integration of del f will be equals to integration of x del x divided by x square plus y square plus z square raised 5 by 2. Now what I can do is I can let x square plus y square plus z square is equals to u square. So from here I'll get 2u du or is equals to 2x dx. So from here this 2 can be balanced by this one, so this will be equals to integration del f is equals to integration u du divided by u square raised 5 by 2, which is from where we'll get f equals to integration u du divided by u raised 5, which is equals to integration du divided by u raised 4. And if I integrate it, it will be equals to 1 divided by 3u cube, it will be minus 3 plus c. Now if you see that in question they have given us that f of 1 is equals to 0. So from here we'll get f of 1 is equals to minus 1 by 3 plus c equals to 0. So that basically gives me c as 1 by 3. So if I plug in this value of c in f, so my f will be equals to minus 1 by 3 u cube plus 1 by 3, which is equals to 1 by 3 times 1 minus 1 by u cube, and value of u is basically, if I plug in value of u, so it will be 1 minus 1 by x square plus y square plus z square raised 3 by 2. So this is the function f for which the given conditions satisfy. Let's move on to discuss the next question. So the next question is find the angle between this surface and this surface at this given point. So we are supposed to evaluate angle between the given surfaces. So angle between given surfaces is same as the angle between tangents at those surfaces at any general point. So tangent at this surface, let's name it as S1, is given by, let's say, R1. So it will be equals to 2x I cap plus 2y j cap plus 2z k cap. Likewise at R2 it will be equals to 2x I cap plus 2y j cap minus k cap. So and tangent at this point will be basically equals to R1 at 2 minus 1 2 will be equals to 4 I cap minus 2 j cap plus 4 k cap. Likewise tangent at given surface S2 at this point 2 minus 1 2 will be equals to 4 I cap minus 2 j cap minus k cap. So angle between these two tangents will be given by cos theta is equals to dot product of R1 and R2 divided by their absolute values. So it will be equals to 16 plus 4 minus 4 divided by square root of 16 plus 4 plus 16 times 16 plus 4 plus 1, which is equals to 16 divided by square root 36 divided by square root 21, which is equals to 16 divided by 6 square root 21, which is again equals to 8 divided by 3 square root 21. So from here my theta will be cos inverse 8 divided by 3 square root 21. So we'll be ending this video here only, otherwise it will take a lot of time to upload. So we'll discuss remaining questions in the next video. Thank you for watching, and please do like, share and subscribe the channel.